Dear students, in this session we are going to see about dielectrics and their polarization. What is dielectric? A dielectric is an insulator. So it is an insulating material. When the external electric field is applied, so this insulator will develop a dipole moment. That means in an insulator, in a particular certain type of insulators, when the external electric field is applied, the dipoles are created. So whenever there is a dipoles are created, it will possess dipole moment. So that type of insulator is called as a dielectrics. So we can differentiate that. So what is the dielectrics and the insulator? So all the dielectrics are insulator, but not all the insulators are dielectrics. In simple words, we can say that the dielectric is a material which can store the charges in the form of dipoles. That's why we can say that the dielectric is a material which possesses the dipole moment when the external electric field is applied. Next, we will see that types of dielectrics. Polar dielectrics and nonpolar dielectrics. So polar means what is dipole? Dipole means two equal and opposite charges separated by a small distance. Let us take the water molecule H2O. There is a 2 hydrogen and 1 oxygen. So oxygen has a 2 minus and hydrogen is each hydrogen is a plus plus. So these two, the center of mass of these two hydrogen atom is here and the center of mass of the oxygen atom is here. So in this molecule, the positive and negative, the equal and opposite charges are separated by a small distance. Hence this water molecule is a dipole. It possesses dipole moment. Similarly for the HCl molecule also, hydrogen plus and Cl minus. So the center of mass of the hydrogen and the chlorine are separated by a small distance, equal and opposite charges, hence it exhibits dipole moment. So in simple words, without external electric field, without applying the external electric field, some of the certain material possess the dipole moment. That type of the dielectrics is called polar dielectrics. So again I will say that without external electric, E0 is an external electric field, applied electric field. When the external electric field is 0, even in when the external electric field is 0, that is a certain molecules exhibit the dipole moment. That type of material is called as a polar dielectrics. The nonpolar dielectric means here it is H2, N2 and O2 are not at all having a equal and opposite charges and there is no permanent dipole moment occurs even in the absence of external electric field. So when there is no external electric field is given, certain molecules not at all having a permanent dipole moment, that is a nonpolar dielectrics. Certain dielectrics having a permanent dipole moment even in the absence of external field is called as a polar dielectrics. So what is the polarization of the dielectrics? It is very simple. Polarization is a process of developing a net dipole moment where the dipole moment will be produced in a dielectrics when the external electric field is applied. That means when the external electric field is applied in the dielectric material, the dipole moments are created. That means dipoles are created. That process is called polarization. That is, in a dielectric material, when the external electric field is applied, the dipoles are created and hence a net dipole moment is arised or developed. That process is called polarization. So now we will see that what happens in the polarization in the nonpolar molecules and polar molecules. So let us see the polar molecule. It is a polar molecules means it possesses a permanent dipole moment even in the absence of external electric field. Yes, in the external electric field is E0 represents the external electric field, applied electric field. So when the applied electric field is 0 in the dielectric material, there is no electric field is applied means there is a dipoles present already by natural process because of the structure of the molecule, the alignment of the molecules or the atoms in the molecules. So it possesses a dipole moment, but the dipole moment direction is random. So it is always negative to positive. So here it is this one. For this dipole moment, the dipole moment direction is this direction, this is this direction. Hence, so in the external electric field is applied electric field is 0. So the dipole moments are in the random direction in the polar molecules. Even though it has a dipoles, the net electric dipole is 0 if the external electric field is applied. When the electric field is applied in the polar molecule, so polar dielectrics, all the dipoles are aligned towards the external electric field. So that is, it is aligned towards the, always the dipole moment is moving from negative to positive charge. So all the dipole moments are aligned towards the external electric field. So dipole moment is P. So that is a small p, dipole moment small p. That is equal to Q into 2A. We are studied in the first lesson itself. Keep remember all those things. What happens to the nonpolar molecules? In the nonpolar molecules, in the external electric field is not applied. That is, when the external applied field is 0, there is a no dipole moment. That means there is a no dipoles occurs. Why the nonpolar molecules possess no dipoles? Because the center of mass of the positive and the negative are at the same point. So what is the dipole definition? The two equal and opposite charges separated by a small distance. Here the positive and negative charge, two and equal opposite charges are present in the molecule, but it is not separated by a small distance. Hence there is a no dipole. When the external electric field is applied, what will happen? The positive and negative charges are separated by a small distance, and hence dipoles are created, and there will be a dipole moment aligned along the external electric field direction. So for both polar and non-polar molecules, the dipole moment vector will be along the applied external electric field vector. So very simple. When the electric field is applied for a polar or non-polar dielectrics, the dipole moment vector will be aligned along the external applied electric field vector.